Hello and welcome back to the Blade of Akar channel. You are watching Shenzhen IO, and in the last episode, just to recap, we did this cool down color changing vape pen thing and the Three Kingdoms token machine or token kiosk. It's now time to move on. Shenzhen days, say cheese. So Tilly's now saying, okay, remember when I said I only had one thing to complain about Westerners living here? Well, I have another one, so sorry, but here I go. It's complaining about cheese. That's right, talking non-stop about your precious cheeses and how they don't exist here. Definitely not in the quantity, quality and variety that they do in France or Wisconsin or wherever. Well, it might be hard to wrap your head around the fact that an entire civilization and one of the top culinary traditions in the world was developed entirely without curdled milk solids. But it's true. It happened. Which is not to say I don't like cheese myself. I do. Late at night you might even find me at McDonald's on Shenzhen Road eating cheeseburgers like the gluttonous young modern global citizen that I am. I'm just saying there's plenty of good and legitimate food that exists without cheese, and it's not like you're going to die for a lack of it. Anyway, when you take a picture you don't say cheese in China, because why would we say that? You say eggplant. You heard me. Cheezee. Cheezee. Say it right and it kinda sounds like cheese, maybe. Cheezee. Okay, so we're just getting like these little Chinese lessons. Lessons in Chinese culture throughout the game. Right, so on to the next thing. Personal sandwich maker. Create a working design. Blah 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 blah. From Joe. Sandwich assembler. Yo dogs. Really? I was out drinking last night again and realised, you know what Americans love? Sandwiches. Am I right? Americans can't get enough sandwiches. I sketched out a quick design for a patriotic sandwich machine where you put in white bread, bologna, mustard. It could play a song when it finishes. Haha. More details to come later when I'm less hungover, maybe. So G is saying, I have a keypad that will work for this, but it uses normal X-bus, which will block until a key is pressed. You will figure it out. Will I now? Right. So PSM, personal sandwich maker D1 for my adventurous naming convention. Right, let's have a look at this bad boy. Personal sandwich maker. Keypad is an X-bus input connected to a keypad. Bread, meat, cheese and mustard are simple outputs connected to mechanisms that dispense those ingredients. Flag is a simple output connected to a motor that raises and lowers a small American flag when a sandwich is complete. When a value is available from the keypad, read it and dispense a sandwich using the information in the following table and the verification tab. Right, 1. Sandwich time. Dispense a sandwich with meat, cheese and mustard. 2. Hold the cheese. Dispense a sandwich but don't add cheese. 3. Extra mustard. Dispense a sandwich with extra mustard. Okay, let's have a look at what it's expecting us to interpret here. So, when we receive a 1, we're going to do bread. Meat, cheese, mustard, bread, cheese, ham, spam. And then we're going to raise the flag for, what is that, 3 ticks, 3 seconds, 3 pauses, whatever they are. And when we receive input 3, we're going to give extra mustard. So we're going to see bread. Oh, did I say the extra bread at the end? Maybe not. Bread. meat, cheese, double the mustard, and then bread again, raise the flag. And for input 2, we're going to see bread, meat, no cheese, straight to the mustard, then bread, then the flag. Okay. So, off the top of my head, it seems like a pretty basic thing. But I'm guessing there must be some kind of catch to it. Maybe the keypad is the issue here, I don't know. But let's start anyway. So I'm getting one basic input coming in. So the bit that dishes out the stuffs, that's going to need a pin. We're going to need several pin outputs, aren't we? Is that where this comes in? We've got one of those there. I wonder. And then we'll probably need another like controller jobby. I probably need a bigger one, but I'll move to the bigger one if I need it. Let's for instance say that's, let's shrink this down a bit. Right, so there's the configuration. So cheese P0, meat P1, bread P2. So that is 001, 010, 100, if my understanding's correct. Let's just do a quick, that should have an SLX on it for a start, right? SLX X0, and then for argument's sake I'm just gonna move 1 to X3, that's gonna go to X0 here, and then I'm gonna say SLX X0, and then if X0, yeah, I don't care really about the value, move, if X0 is 1, move, let's go with 111 to X1, yeah, oh that should be X0, okay, and then X1 out to, can I do it that way? Can I do it that way? Partner sleeping, 111 and 100, 100, 100. Let's just add a slup, and do I need to care about? I'll just put sleep in there as well. Just yeah, 100, 100, 100. Okay, that works. Now, if I do 101, let's say. Yep, so the middle pin's now off. Right, now we just need the orientation. So 001. 001. So yeah, 1010. So 001, 010, 100, or whatever combinations in between. So okay, we got that figured out. And I guess we need something for the bread, and we need something for the flag. This is where we're going to need a bigger board, I think. So we're going to test. We don't need to test, right? Because no matter what, we've got to have 2 slices of bread. So we move 100 P1. No. We gen P1 0? Gen P1 0 what? 1 0. I can't remember the command now. Let's X1 not X0. Let me just add a sleep in there and then just see what 1 1. Okay, yeah. Okay, but that's because it keeps coming back around, so we keep getting the pulse, so that's fine. Okay, that seems to work for me. Now we've done that. The immediate right. So the next thing we need to consider is that we always deliver the meat, right? We always deliver the meat. The only options are either no cheese or double mustard. So straight away we're going to move 010 to x3. I'm not sure how that's going to work. So this is a sequence now, so I need to sleep 1, and then do I need to go move 000 to x3 to reset? Right, so I need to store the signal from x1, so move x1 to AC, I guess. Don't think I need anything else. Then right, so test equal AC2. So if it's exactly 2, if it's not equal to 2, then we'll move. Where's cheese? Oh no, that was cheese I was sending. So I was sending the wrong one there. So I need 001, sorry, for the third pin. I need to move now 010, right? Because if it's not the second option, there was going to be no. If it's not the second option, there's always going to be cheese, right? And then we'll sleep 1. That's optional as well. We need to move that to x3. Now, if it's equal to 3, we then need to we've done the meat, yeah, we've done the cheese, so now we need to do the mustard. If it's, let me just get this in my head. Right, if it's, aha, right, if what's in the accumulator is equal to 3 or not, we need to move 100 to x3, and then it's down to the sleep. So we either sleep 2 or sleep 1, right? And then we're running out of instructions. Yeah, it's interesting, but let's just crack on anyway, right? Anyway, given that I know I need to add the flag code and somehow get that in there, I'm just going to try and test this through, see what happens, and immediately we're failing. Why are we failing? That's interesting. Let's step through this slowly. So if we received 1, we've got that in the ACK. So we, no matter what, we gen P1 for 1 tick, which we've done. We then move 001 to x3, which we do. I sent the wrong value, obviously. I sent mustard. Right, that's me being silly. So that's got to be 001, and this one's got to be 100. Right. Okay, now what's going wrong? We're sending bread before mustard. Why are we not sending the mustard? So move 001 to X3, which should set off the mustard, which it does. Oh, I've got those. I put them on the blooming same thing. Right, that's what the problem is. Right, okay, that's a bit more healthy. But yeah, obviously no flag. But look at that, the rest of the sequence stuff is working beautifully. So I've just got to figure out the flag conundrum. Okay, I've been trying to think about this, and I can't figure out, in my head at least, a way to optimize this in a way that allows me an instruction to send a gen pulse down to this. I just can't see. I just can't see how I could do that, because any kind of looping or whatever just adds more instructions anyway. Okay, there we go. Right. And instead of gen P1, what I'm going to do is I think I'm going to move this back a little bit. There we go. What I'm going to do is I'm going to move 1 to X2, right? And then down here I'm going to move 0 to X2, right? And that gives us this kind of sequence thing over here. So if I SLX X0 and then I can say test equal X0 and 1. If it is, then we are going to move gen P1 1 0. Okay, we're going to send a pulse to put down the bottom piece of bread. And then we'll just loop back for the sleep, and then if it's not, we're going to gen P1 1 0 for the closing piece of bread, and then we're going to do another gen on sorry, that's the wrong pin, P0 P1 for 3 and 0, and then just loop back. I think that's all we need, but I don't know. We'll see. Well, let's have a look. Okay, now we've screwed something up. How have we done that? Okay, we're losing sleeps. I wonder if I have a kind of sub-controller that does the core part of this, and then all of this sequence here in the middle we need to change, move it out over into here. We need to move the value of X1 to AC, because we did that over here but we haven't done it over here. So let's try this again. There we go. Right, pop. Right, okay, we've done the same over here. So we just need to move X3 to AC, because we don't really care about the value at that point. Let's try again. There we go. There we go. There it is. Speed this up. Simulate. Sweet. We're... Oh, there's a lines of code one now. Okay, we're a little off point on cost. We're on point with power usage. We're on point with lines of code. So I'm not sure what I could have done to reduce the cost. Hang on a minute. 1, 2, 3, 4, 5, 6, 7. That's 8 instructions. So actually I could use one of these bad boys, and then I think, and then grab that code, shove it in there, and then X3 becomes X1, and then x1 becomes x0 up there, and then I need to rejig that bit. No, I need to rejig that bit there, and then do that, take that away, dump that. Let's try again. Voila! We've reduced the cost. There we go. I'm on point now with well, I wouldn't say on point, but I'm with the masses in that I'm around the same cost, same power, and same number of lines of code. Let's return to the email. Here we go. I'm sorry, I really am trying my best to come up with good ideas, but obviously, as you pointed out, I have more work to do in that area. Please give me another chance. I swear I'm going to redouble my efforts and work extra hard to create a successful product for you. I promise. Please disregard the previous message. Hit the wrong button. Haha. Okay, so Joe has had a bit of a ticking off for coming up with some duff ideas. That's brilliant. Okay, let's look at the next project. So Lily Wu is now touting a carbine target illuminator. A what? We have a deal to create a highly portable infrared targeting device that automatically switches emitter modes based on a range. At long range the aiming laser is on. At mid range the aiming laser switches to half power and turns on a 20-degree flood emitter, and at close range it switches completely to a 60-degree flood. I've placed a copy of the table on your desk as a mounted add-on for any type of carbine weapon. It has the potential to do very well across government and law enforcement agencies. So Carl is piping up and saying, I'm going to nope right out of this one if none of you mind. So he's very anti-war stuff. Let's have a look at it. Okay, so I think there's a design in the documentation which I'm probably going to have to dig out. But let's get to... what? I was not finished. Thank you very much. CTI D1. Okay, right. Radar out, radar in. Okay. Radar out is a simple input connected to a miniature radar unit that indicates when it fires a radar ping. That was radar out. Radar in is a simple input connected to a miniature radar unit that indicates when it receives a radar ping. Laser is a simple output connected to a variable intensity infrared aiming laser. Flood 20 and Flood 60 are simple outputs connected to infrared flood illuminators with 20 and 60 degree beams respectively. Measure the delay between the radar out and the radar in pulses and control laser flood 20 and flood 60 as specified in the carbine target illuminator range diagram, which can be found in the supplemental data section of the manual. Right, I'm going to have to get my docs, my documentation. So it's obviously in reading time I'm going to have to employ a loop which modifies an accumulator per time tick so that we get a count of the time units, because we've not been provided with an RTC, nothing else is recommended, so it's going to be fairly fundamental on that side of things. Let's just quickly slap this out. Let's have a look at the radar. The verification term shows the radar out, the radar in, so that's one tick down there. There's 3 ticks. Right, let's start that again and figure out why we've got too many numbers. So we're moving 1 to ACK because we're going to gen P1, which gives us a sleep, and then we're going to add a sleep for 1 and add 1, that gives us 2. Okay, Alright, I'm just going to set this to 0 to start with then, because I think we're just jumping ahead there because of the way the logic's working out. So let's just try this. 1, jump, 2, move, 2, 1, 2. That seems right to me. Okay, let's reset that. Now we've got some... Are these all pins? Yes. They are pins. I wonder if I can use that funky thing again. I wonder if I can use one of these again and just do this. And then, I don't know, X3 there. See, maybe I'm doing this wrong actually, because I should be doing it off when I receive the pulse rather than a predefined amount of time between the pulses. I grab this note a minute. I don't want to get rid of this code right now. Don't do the sub 8. And then I just remove all of that. And then do this bit. Paste that in the note, and then let's just see what happens now. Right, signal come in. Is it equal to 100? Yes it is. Now start looping. Give us the time. Okay. Right. Okay. Yeah, that's right. Lasers at 50. We're sending 10. Flood 20. That's working. It's working. That's working. Okay, that's brilliant. So I can now get rid of this. Now, question is, can I fit this in a smaller board? 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I can't see it right now how I can make this any more economic. So I'm just going to run the simulation. Hopefully it's going to pass throughout. It's looking good. Hey, so yeah, not very good on production costs. And the lines of code, apparently I'm about where most people are, but if most people are getting a lower production cost, I'm not sure how they're doing that. But the power usage is, you know, it's pretty much where everyone else is at the moment. Like I said before, I'm not going to dwell too much on making things overly efficient on at least my first pass through this. If I figure out more efficient ways of doing it, then I might throw up some kind of better solutions on the channel, which you'll be able to get if you're getting stuck yourself. But for now, I'm just going to crack on with this. So I'm going to return to email. I'm relatively happy with that. I mean, the production cost is irking me a little bit, but I just can't see how I'm going to fix that, because I've got 9 instructions in there and I just can't see how I can make that any less. So let's return to email. Okay, Carl Teskey, we did it. We made some kind of thing that goes on another thing that's made for killing people and helps them kill people ever better. Yay, go us. And then Lily saying, Carl, I understand your concern, but let's take this offline. Yeah, you're going to get a ticking off, pal, just like Joe. There's a bit of unrest among the ranks in Shenzhen IO, or the Longteng Shenzhen Communications Company Limited Corporation, whatever they're called. Anyway, I'm going to leave this one here. I hope you enjoyed it. If you did, don't forget to hit like, share and subscribe. And if you've got any better solutions for me, share them in the comments. I want to hear your ideas on how I can make some of my designs better. Be interested to hear your thoughts. Anyway, thanks for watching and bye bye for now.